Looking at the second part of lesson 1.4, solving systems of linear equations, we are going to be looking at solving three variable equations, right? So think in terms of like a 3D printer or robotics sort of things, running a robotic surgery machine, right? They need coordinates left and right, up and down, side to side, right? So 3D printing, you'd have to have three coordinates or three dimensions. So you're going to have three variables, x, y, and z, and three separate equations, and your solution will no longer be an ordered pair, but it will be called an ordered triple. So we can have, again, exactly one solution where the three planes would intersect at one point. You may have where infinite solutions where they all meet along a line like we see in the graphic. And there may be something where there is no solution, where they form some sort of triangle or the other shapes that we see, or they're all perpendicular to one another. There would also be no solutions. So there's going to be three steps involved here. We're going to rewrite the linear system in three variables as a linear system in two variables by using either substitution or elimination. In step two, we're going to solve the new linear system for both of its variables and substitute the variables found in step two into one of the original equations and solve for the remaining variable. If at any point we get a false statement, such as 0 equals 1, there would be no solution. When we do obtain a false solution but obtain an identity, such as 0 equals 0, it has infinite solutions. So we have to be on the lookout for that happening as well. So here are our three equations. 4x plus 2y plus 3z equals 12, 2x minus 3y plus 5z equals negative 7, and 6x minus y plus 4z equals negative 3. So we are going to rewrite this system as a linear system in two variables. So to do that, I am going to basically run the process of elimination two times. I am going to use elimination between these first two equations and again between these last two equations. I'm going to kind of color code this for you. So to use the first round of elimination, if I multiply this all by 2, right, that will give me my first equation I'm going to leave, 4x plus 2y plus 3z equals 12. Right, that's just copying down. And now for the second equation right here, I'm going to multiply it all by 2. 4x minus 6y minus plus 10 z equals negative 14. Okay, now if I can subtract these, I'm going to get 4x minus 4x is going to cancel. 2y minus a negative 6y would be 8y. 3z minus 10z would be negative 7z. And 12 minus a negative 14 is 26. Right, so I am left with a equation there that has both y and z. I have eliminated x. I am going to do this again using the second and third equations. So if I multiply this second equation now by 3, I will be able to eliminate x again. It's important that once you commit to eliminating a variable, that's the one you stick with. So 2x times this 3 is 6x, and then 3y times 3 is minus 9y, plus 15z equals negative 21. Right? Now I have in my third equation here, I have 6x minus y plus 4z equals negative 3. And if I subtract these again, right, I am now trying to run elimination using equations 2 and 3. I get 6x minus 6x is 0x. 9y minus a negative y is negative 8y. 15z minus 4z is plus 11z equals, and then 21, negative 21 minus a negative 3 is negative 18. Right, so now I have two variable equations. They're not x, y like we did in yesterday's lesson, but they are both y, z equations. So I have these two equations now that I am going to work off of for step 2. Right, so I have 8y minus 7z equals 26. And then I have negative 8y plus 11z equals negative 18. And now if I add these equations, in the past we've just subtracted, but now if I add, right, I get 8y plus a negative 8y. Those cancel out. And if I get negative 7z plus 11z, I get 4z, and then 26 minus a negative 18 would be 8. Right? So when I'm working to solve here, I can eliminate this 4, right? I can move it away. I get z equals 2. Right? So that is the first part of my solution, right? My solution is going to be an ordered triple, x comma y comma z. And I just found out that z is equal to 2. Okay? Now I can start in step 3 substituting back into equations. So in step 3 of your notes, and I'm going to leave it on this screen here because otherwise I lose all my progress. We are going to keep solving for additional variables. So now that I know z, right, I know z, I can substitute in to one of these two equations to find y, right? So 8y minus 7z, which I just learned is 2, is equal to 26. So 8y minus 14 equals 26. Right, so now if I work to solve for y, I add the 14 away, 8y equals 40. And when I divide away that 8, I would get y equals 5. Right, so now I have this in my XYZ ordered triple. I now have 2 of the 3 complete. And then I will go back to Let me get a new color. Right, I will go back to one of my original equations, and I'm going to sub in y and z, right? 4x, which I don't know yet, plus 2y, which I just learned was 5, plus 3z, which I know is 2, is equal to 12. Right? So now I have some order of operations things to work on. 4x plus 2 times 5 is 10, plus 3 times 2 is 6, equals 12. I get 4x plus 16 equals 12. Subtract away the 16, right? Subtract 16 from both sides. I get 4x equals negative 4. So then x would be negative 1. Right? I know these are kind of intense, but it's really the same as yesterday's lesson with elimination, just kind of an extreme version of that, right? So you'll go through some practice problems, and then that'll bring us to the end of chapter 1.